Hi friends, Captain Deepak once again. It's been a week since India's heartbreaking loss to Australia in the Cricket World Cup. But we need to keep our heads high and move on, and that's exactly what we'll do. So moving on, this is part 2 of the video on question 10 of Hindship. In the first part, the link of which I have given in the description, we learned on how we arrive at the formulas for correction to be applied to the aft and midship draft to get hydrostatic draft. Now in today's video, we solve the question itself. So let's take a look at the question. So this is the question given to us. MV Hindship arrives at a port in water of relative density 1.012 with drafts forward 6.15 meters, aft 7.22 meters. A sailing draft in water of relative density 1.025 was forward 5.33 meters, aft 5.98 meters. Calculate the weight of cargo discharged at that port if 85 tons of fuel and fresh water were consumed in the port. I think the question is pretty straightforward. We need to calculate how much cargo was discharged. Okay, let's go about this in a stepwise manner. Okay, let's go to step 1. Now we have the arrival drafts forward and aft. So what do we do first? The first thing that we do is to calculate the mean arrival draft. And how do we do that? Very simple. It's the average of your forward and aft drafts. So 6.15 plus 7.22 divided by 2, which is equal to 6.685 meters. Now what do we do? Now we find the LCF for this mean draft, which is 6.685 meters. Now if you go to your Hindship tables, and a snapshot of which I've actually put in this video, you start interpolating or use your stats mode of your calculator. So the draft is 6.685 meters, which means it's between 6.60 and 6.80. And if you look at the sixth column, your LCF should be between 72.005 and 71.806. So do your calculations, do your interpolations, and now you get the LCF for the mean draft 6.685 meters is equal to 7.92 meters. Now here's my question to you. Does LCF change for the same draft at different relative densities? I hope you remember the first video which I presented on Hindship basics. I've again given the link in my description. Now, if you look at the video and if we are clear with our basics, then we know the value of those items whose units are in meters. That does not change with relative density for the same draft. In essence, it means that even if you were at a draft of 6.685 meters in salt water or fresh water or any other relative density, your LCF for that draft would remain same. And so your LCF for a mean draft of 6.685 meters in salt water, relative density 1.012 or fresh water is the same. So we now have our LCF. Now moving on, we know that the after draft is 7.22 meters. What have we learned from part 1 of our video? That the correction is equal to trim into LCF divided by LBP. You substitute the values and you'll get the correction as 1.07, which is the trim difference between 7.22 and 6.15, into 71.92, which is our LCF for the mean draft, divided by the LBP of MV Hindship, which is 143.16, and so you get your correction as 0.537. Now let's move on. Now here's my question. So you've already got the correction. So is this correction positive or negative? This is the correction to be applied to the aft draft, right? So is this correction positive or is it negative? Now, we know from our earlier videos, since the vessel is trimmed by stern, it means that the COF, your pivot, your seesaw theory, is abaft of midship, and hence the correction to be applied is negative. If it was forward of midship, which means that the ship is trimmed by head, then it would be positive. So in this case, it's negative, and hence your hydrostatic draft is equal to the aft draft minus your correction, which is equal to 6.683 meters. Now I hope that this is clear, and now we'll move on to the next step. So what is the next step? We already have the hydrostatic draft, right? So we're going to find the displacement for the hydrostatic draft from the Hindship table for a draft of 6.685 meters. Again, go to the Hindship tables, do your interpolation, and you get a value of 13572.7 tons. Now, again, a question. Does displacement at the same draft change with relative density? Yes, of course, right? We already said that the units, the items with units which have in meters, those are the ones that do not change. Everything else like displacement or TPC or MCTC, that changes with relative density. And the tables given in Hindship is for salt water. So how do we find out the displacement for a draft of 6.685 meters in relative density of 1.012? You just have to multiply it by 1.012 and then divide it by 1.025, which is equal to 13400.6 tons. So your arrival displacement in relative density of 1.012 is 13400.6 tons. I hope this is clear, and it would be actually important for you to go through the first video on Hindship basics to understand. I mean, that's where I've explained to you how do you calculate displacement and other values in relative densities, which is different from salt water. So if you still have doubts, I would actually suggest that you go through those videos. But otherwise it's pretty straightforward. Hindship gives you the displacement in salt water. So if you want to get the displacement in any other relative density, divide it by 1.025, which in essence gives you the underwater volume, and then multiply it into the relative density of whatever relative density that you want. Okay, I hope this is clear, and then moving on. So we have the arrival displacement. Now, if you go about in a similar fashion, you also know the departure drafts, and you also know the water density of water, which is in fact salt water. So in a similar fashion, as shown in step 1 and step 2, you can actually calculate that your departure displacement is 11232.3 tons. You already have the arrival displacement. So what is the reduction in displacement? It's arrival minus departure because you've discharged cargo, which is 2.168.3 tons. But in port, you also consume 85 tons of fuel and fresh water. So the cargo discharge is of course going to be the reduction in displacement minus what you already consumed, right? So it is 2168.3 minus 85, which gives you your answer that 2083.3 tons of cargo was discharged in this particular port. I think we've come to the end of this video. I think in stability, you need to just go about in a systematic manner, just analyze what data you have, and then go in a step-by-step manner. And then if you do it in that way, I guess stability is probably one of the easiest subjects to score marks. In any case, if you still have any doubts, then let me know and I shall help. And till my next video comes, this is me signing off, and thank you for watching. Thank you and take care.